Hello, everyone. Today, I'm going to talk about our research project about the gist of abnormal in prior mammograms and its application. Is that right? Okay. And its application for predicting a subsequent breast cancer based on prior mammograms. It's a collaboration between our group at the University of Sydney, Harvard Medical School, and the Department of Psychology at the University of York. Let me start with a bit of background. In past few decades, several studies have been dedicated to modeling and understanding of medical image interpretation process. Indeed, most of the researchers used eye tracking data to reveal the medical image interpretation process. In spite of the usefulness of eye trackers, it doesn't provide any information about global processing of image. It only provides us some information about local processing of image. However, we know, especially in medical image interpretation by expert, global processing of image, experts' first impression from the image plays an essential role in interpreting the medical images. So, this global impression from image, or this holistic processing of image, is often called the GIST signal or the GIST response. Our study focuses on the GIST signal in prior mammograms. To further clarify what I mean by the GIST signal, let me show you our experimental process. So, first, a cross symbol appeared in the center of a screen to encourage readers to look at the center of image. Then a breast was presented, a mammogram was presented for a half second. This was then followed by presenting a white mask to end visual processing of the image. And finally, the readers were asked to provide a score to indicate whether they would recall the patient or not. So let's play it together. So, in case you were interested, that was an abnormal case and categorized correctly as an abnormal case by all 23 expert radiologists participated in our study. It's quite promising. This highlights the importance of global processing. So let's go back to our model. So basically, most of the previous studies in global processing of image assumed that this global impression, this GIST response, restrict the further eye tracker, eye movement of radiologists. So it contained where information about localized source within the image, information about probable locations of the lesion. However, from psychological studies, we know that the GIST signal may contain both what and where information. A brief glance at a bookshelf will give you information about whether it's a collection of textbooks, like here, or fantasy books. And in contrast, glimpse of a kitchen in the morning can direct your eye movement to probable locations for toaster. This time, the GIST signal contains information about a spatial layout of your scene to constrain your further eye movement to probable locations for toaster. The mainstream of GIST studies in psychology assumed that GIST contained the second class of information, where information. However, recently our colleague at Harvard Medical School showed that the GIST may contain what information as well. They showed that if women had detectable breast cancer in one side, expert radiologists were able to categorize the contralateral mammogram, the normal contralateral mammogram, as abnormal cases at above chance level. Those contralateral mammograms, they were cancer-free. And it was pretty interesting that the expert readers can detect the holistic image statistics to categorize them correctly as an abnormal case. So we decided to do the experiment to investigate the strength of the GIST signal in prior mammograms. In the prior mammograms with normal reports based on usual reporting and presentation scheme, but from women who eventually developed a breast cancer. We did our experiment using the protocol I've explained earlier and asked our 23 radiologists to give us a score to indicate whether they would recall the patient or not. We included 4 different categories of images: cancer category, normal category, prior Vs, prior INVs, and contralateral images. The cancer category contained biopsy-proven malignant lesion. Cancer, normal cases were normal cases, at least based on 4 years of follow-up. Contralateral mammograms were normal mammograms, contralateral to a malignant lesion. Prior Vs category contained mammogram with retrospectively visible signs of cancer, but initially screened as normal cases. But all those cancer signs were non-actionable cancer signs. We did, and prior INVs category contained prior mammograms without any visible sign of cancer from women who eventually developed a breast cancer in our subsequent screening. We've done pairwise comparison, and each time the normal category was served as our baseline, we generated the ROC curve and calculated the area under the ROC curve, the AUC values. The AUC of 0.5 shows chance level, and the AUC of 1 shows the perfect performance by our reader. As you see here, in all pairwise comparison, an average reader was able to distinguish the positive cases from normal cases. This means that even before an overt sign of cancer was present in our cases, the expert readers were able to detect the cancer. That concludes my presentation today. However, I'd like to show you some results about our ongoing work to use this GIST signal for predicting a subsequent breast cancer. Indeed, we developed a model called MyRisk using machine learning and computer-extracted features. Combined with the GIST signal, we showed that in a preliminary experiment, we showed that our model is able to predict a future breast cancer with an accuracy above 80%. Well, that's for me today. Thank you very much for listening.
Thank you very much, Ziba. Does anybody have any questions for Ziba today? Well, I'm going to try my best. So my question goes to sort of the implications of this for practice. So I wondered if you could tell me a bit about what the usual process is for diagnosing a breast cancer in terms of who's responsible, the breast cancer physician, the radiologist, and in relation to your results, the radiologist did better. What difference would that make if we were taking this forward?
You know, currently in practice, we use double reading in Australia. It means that 2 radiologists go through the image independently, and in case of disagreement between them, we will ask a 3rd radiologist to do the experiment to do the image interpretation for us. Here we say that maybe the first impression that a radiologist have about the image can be used, because this first impression might be canceled out during the usual interpretation, during the usual fixation, further fixations on the image. So what we are trying to say is that maybe we should record this first impression of the radiologist as well. And maybe we can use this first impression from the radiologist, combine that first impression with computer-extracted features, some machine learning algorithm to predict a future breast cancer. Ultimately, if you success in generating a model for predicting a future breast cancer, can be used for like tailoring the screening pathway and screen less people in lower risk and screen more high-risk population.
Thank you very much for clarifying that.